Hello, I want to review one of the things that you talked about in your trig class, and it involves inverse trig functions. So first I'm going to review some of the definitions, and then we're going to take a look at the example problems. So when we talk about these trig functions, there's a couple ways we can define them. For example, we can think about points on the unit circle, but today I want to talk about the right triangle definition. And so for each trig function, we have a corresponding ratio of sides. If we're talking about sine x, our input is always one angle in a right triangle, and the output is a ratio of sides in the same triangle. For sine, that ratio is opposite over hypotenuse. So now let's think about the inverse function. Well, one of the things we know about an inverse function is that the role of input and output is going to switch. So for inverse sine, that means that our input is now a ratio of sides, and our output is an angle. This idea from the definition of an inverse function is what we're going to use to solve our problems. And the problems involve compositions of trig functions and inverse trig functions. This is something that you talked about in trig class, but it was probably mentioned only briefly, so I want to review the steps. Our first example here, we have sine of inverse sine of 1/2. This problem is actually very easy. The answer is just 1/2, and that comes from the definition of an inverse function. Let's look at another example. This one's a bit more complicated. So here we have sine of inverse tangent of 3/4. And the approach we're going to take is to draw a right triangle that represents the setup for this problem. So for our first step, we're going to define an angle. Remember that for inverse tangent, the output is going to be an angle. We'll call it theta. And the angle that we're talking about belongs to a right triangle. And we know something about the sides in that right triangle. That fraction 3/4 tells us about the ratio of sides. And for tangent, we're talking about the opposite side and the adjacent side. So we need to draw a triangle that shows all of this information. And I've done that here. So notice I labeled the opposite side as 3 and the adjacent side as 4. If we're talking about a right triangle, we can use the Pythagorean theorem to find the missing side. So I set the algebra up and did that here. In this example, our missing side is the hypotenuse, so just make sure that your unknown is C. Our example here, the third side of our triangle has length 5. And now that we know all three sides of our triangle, we can find the sine of the angle. That's what we're looking for. So I set up the ratio of sides that defines the sine. It's opposite over hypotenuse. In this problem, that ratio is 3/5. So that's the answer to our problem. The sine of inverse tangent of 3/4 is equal to 3/5. All right, let's take a look at another example. This one's a bit more complicated. The steps that I use are going to be exactly the same. I'm going to put this information in the problem into a right triangle setup. So first, remember that inverse trig function sine to the -1 gives us an angle. We'll call that angle theta. And then I'm going to draw a triangle that represents that ratio 1/3. If we have inverse sine, we're going to put that ratio into the opposite and hypotenuse of our triangle. I set all of that up in the following figure. And then our next step is to solve for the third side. We're going to use the Pythagorean theorem to do that. So here's the algebra that we go through to get that missing side. Just notice where I plugged in the value of the hypotenuse. That's important for this setup. All right, our missing side has length 2 root 2, and so there's the right triangle that we're talking about. And now we're ready to use these values to find the secant of theta. The definition of secant is 1 over cosine, and when I combine this with the definition of cosine adjacent over hypotenuse, okay, when I take the reciprocal of that fraction to get secant theta, and for the triangle that we're looking at here, that ratio is 2 root 2 over 3. This particular problem is asking for the value of secant squared, so we're going to take the number that we got on the last step and square it. I laid that out here. And the final answer to this second example is 8/9. Okay, I posted a few problems that I'd like you to try, so write those up. Please bring them with you and give them to me at the beginning of class tomorrow. Thanks.